We saw the case where firms are earning profits in the short run because that price was above ATC, which meant that firms could earn a profit in the short run. Firms were entering, and then we went back to zero profit. So now we're going to show the case where firms produce at a loss in the short run. And why would a firm ever want to produce at a loss? So it might help to just run through a numerical example to explain that. So we know that profit equals total revenue minus total cost, and I'm just going to break out the total cost into variable plus fixed. So we're going to take total revenue, subtract out the variable cost, subtract out the fixed cost, right? Whatever's left is profit. So I just made up some numbers here just to illustrate. I'm going to have two different scenarios. So suppose we have $100 revenue, variable is 125, fixed is 75. So clearly we're going to have losses here. So we have two choices here, given that remember, we can't control the price that's making up this revenue here, so the only thing is, given that, and then given our profit maximizing price, do we want to produce? Well, we have two choices. If we produce, then we end up with these numbers, and we're going to lose 100. Or we can shut down, in which case we're not going to earn any revenue, but we're also not going to have any variable cost, because we're assuming variable cost is the cost that we're going to incur only if we produce output. So we can get rid of that variable cost, but we can't get rid of the fixed cost. So that's the whole idea here. We're going to have this fixed in some short run period. We can't do anything about this fixed cost, so that if we shut down, right, this goes away and we're just left with that fixed cost. So in this case, we do want to shut down, right, which just means don't produce anything. Because we're gonna lose even more. If we bring in $100 revenue, it's gonna cost $125 to bring in $100 of revenue, right? Nothing we can do about this, so we don't want to do that, right? That's the case where we would want to shut down. But if we change the numbers, suppose that revenue is 100 at the current price, variable is 50, again fixed cost is 75. Now if we produce, we're going to lose 25. If we shut down, right, this goes away and we're just going to lose our fixed costs. We're going to lose 75. So in this case, it does make sense to produce, because again, in the short run, we can't do anything about this. We're going to lose that 75. The only question is, should we produce, bring in $100 in revenue? It's going to cost us that $50 in variable cost, so it would be worth it to go ahead and produce. We're going to lose this anyway, so we'll bring in that $50, right? Then we're going to lose the 75, so we'll still lose 25, but it's better than shutting down, and we lost that opportunity to at least cover our variable costs and pay down at least some of those fixed costs, right? So we can produce at a loss would actually make sense for this firm in the short run. And so basically the condition that needs to hold is that total revenue. If that total revenue is greater than that variable cost, then it makes sense, right? Produce if total revenue is greater than variable cost, and we're looking at everything in terms of per unit. So I just divided by quantity, total revenue divided by quantity is the price. So just per unit revenue, average revenue, and just per unit variable cost, our average variable cost. And I made it greater than or equal to because we're assuming if you're right at that point, just like in our zero profit equilibrium, we were right at the break-even point. We just assume that we're going to still produce if we're right at that point. So the same thing here. This is going to be our shutdown point. If we're right at the point, we're going to assume that we still produce. Nothing really changes because of that, because we're assuming you can adjust with such small quantities that it really would make no difference whether we use that equality or not. So now we can do the demand decrease case and show what this looks like. So that's going to be our condition of whether we want to produce or not, to produce or shut down. Okay, so we're starting in long run equilibrium. We're here P1, every firm's earning zero profit, price equals ATC, so we have zero per unit profit, zero profit. Now something, instead of a demand increase, something causes a demand decrease, which causes that price to fall in the market, and then our firms just take that price as given. We have a new marginal revenue curve, and again, if we're going to produce, we're going to set price equal to marginal cost. So the best we can do if we produce is to go here. Right, we still can't do any better trying to go anywhere else, because we still want to produce all the units for which marginal revenue is greater than marginal cost. And by the way, just a little aside here, suppose this curve kept going over here, which it very well might, then you would have a point where marginal revenue because marginal cost here, but this would not be a profit maximizing point because you can always do better in that case by continuing to produce, because then I would have additional units where marginal revenue is greater than marginal cost. I might as well keep going. Then I would stop here, right? So the marginal revenue equals marginal cost point is always on the upward sloping part of your marginal cost curve. So again, if we're going to produce, that would be the point we'd want to produce. So we're always going to go to our profit maximizing point. In this case, we're going to have a loss, but it's still our profit maximizing point. In this case, it's a loss minimizing point, the best we can do, because we wouldn't want to stop before that because we're giving up that extra marginal revenue compared to marginal cost. We wouldn't want to go past that because then the marginal cost of that next unit is greater than marginal revenue. Best we can do if we're going to produce is to go here, and then that shutdown condition is going to decide whether we actually want to produce or not at that point. And so we would need our AVC curve because now we're comparing price and AVC. So remember, AVC is just going to be U-shaped below that ATC curve. And again, our new price is here. Right? We just have to be a little careful labeling everything here. So our new price is here. If we're going to produce, we're going to set price equal to marginal cost. And since that's above AVC, I do want to produce. I'm covering my variable costs. My total revenue is above my variable cost, or in other words, my price is above my average variable cost at that quantity. Right? My average variable cost at that quantity is here, and my price is here. So I do want to produce here. I will have a loss. So remember, price is here, and for ATC, I'm just going to go up at this quantity to my ATC curve. Right? First, I'm picking my quantity. Right? Then that tells me what's my average total cost at that quantity. It's up here. So this is price versus ATC is my per unit profit. In this case, it's a loss because price is below ATC. So per unit loss is this distance, and then loss per unit times quantity is total loss. And so this area of this rectangle is going to be my short run loss. Again, we have to make sure that we curve this so that we can show we're above that minimum point, so that this line should be above P1 like this. Okay, so we have losses. What's going to happen? If firms have losses, they want to leave. Just like if we had profits, they want to enter. If firms have losses, there's something better they can be doing. There's some alternative that has at least zero profit that they could be earning. So firms are leaving. Again, here's where we were originally. This was our short run equilibrium due to that demand decrease. Now as firms leave, that's a supply decrease, right? And as firms leave, that causes that price to rise. And again, if we are a constant cost industry, which is what we're assuming here, then price is going to rise until it goes back to P1 and we are back to earning a zero profit. So this price is going to rise back to P1 because at P1 all of our firms with our same cost curves are all back earning zero profit. So now we go back to producing Q1, all of our firms, except we have fewer firms. Right? We have a new equilibrium, market quantity falls because we have fewer firms each producing the same quantity that they did originally. We just have less of them. So our equilibrium goes back, price goes back to P1, and now we're back here. Each firm is back at zero profit. We just have fewer firms. And again, we're assuming all firms are identical, so we can't say anything about which firm is leaving. There's just some random selection of firms. It doesn't matter for our purposes. So similar to what we saw with the demand increase case, we have a long run market supply curve at our original zero equilibrium price, and so we can be away from that in the short run. In this case, we were here in the short run, but as firms left, we got back here because only zero profit is going to be an equilibrium, a long run equilibrium. Either we have a positive profit and firms want to enter, or we have a negative profit or loss, firms want to leave, but it's going to have to adjust and get us back to our long run market supply curve. So if we had a demand shift, that was our other case, we were here in the short run, back here in the long run. Right? Demand decrease, or if it was a different decrease, we might be here in the short run, but then firms are going to leave and we're going to be over here. So with a constant cost industry, we're going to end up on that perfectly elastic long run market supply curve at that zero profit equilibrium. So we said that if the price ends up over here somewhere, where, remember, this is going to determine where my profit maximizing quantity is going to be. I'm going to set prices here. I'm going to go here. Prices here. I'm going to go here. So as long as that price ends up above AVC, I'm going to produce. And again, I assumed that if I'm right at that point, I'll still produce, just like if I'm right here, I'll still produce at zero profit. But if I'm anywhere below that, so if that demand decrease was big enough to put the price back here, now that was like the case I showed, the numerical case where I do want to shut down. It doesn't make sense to produce. I can't even cover my variable cost, so that here I do shut down. Which means now we can derive what this firm's supply curve actually is, the short run supply curve. So because if the price is at least at that shutdown point, then this marginal cost curve tells me where to produce. Right? If the price is here, I'm going to set it equal to marginal cost and produce here. If the price is P2, I'm going to produce here. If the price is P1, I'm going to produce here. So remember, a supply curve just tells me you give me a price, I give you quantity supplied. Right? If the price was up here, I'm going to make a profit, at least in the short run, so I'm going to produce here. Right? So this is this firm's short run supply curve. You give me a price, marginal cost curve tells me where we're going to produce. So that when we were looking at ordinary market supply curves, which on our market graph, this was really the sum of all our firm short-run supply curves. And so that was our market short-run supply curve. So we were assuming perfect competition whenever we do these ordinary supply and demand curves. Sum of all our firm short-run supply curves. And again, if I was a constant cost industry, I would then have that perfectly elastic long-run market supply curve. A lot of times we'll just draw it all the way down here to zero. It doesn't necessarily have to start here, but sometimes just for simplicity we'll assume that.